Hello everyone, my name is Brandon Griffin, and today we are going to be doing some forecasting in Excel. We are going to be doing naive forecasting, a simple moving average, and a weighted moving average. Along with that, we will be calculating MAD, MASE, and MAPE, the mean average deviation, the mean squared error, and the mean absolute percentage error. So let's go ahead and dive into it. So what is the formula for naive forecasting? So we have a couple pieces of information. We have our weeks, and we have our sales. This works for a lot of different things. People will call this demand. So we have our weeks and we have our demand. And first, the naive forecast is simply just using the prior year's forecast. So for week 1, since we have no data before that, we're just going to go ahead and leave that blank. For week 2, we need to use the prior period's forecast, or the prior period's actual sales for our forecast. So in week 2, we are going to put 38. It's naive because you literally just put in the numbers from the week before. So if this is 38, that comes from week 1. For week 3, we're going to put in 42, which came from week 2. In week 4, we're going to put in 45, which came from week 3, and so on and so forth. So 40 from week 4, 38 from week 5, and 41 from week 6. And lastly, we are going to end at 48 from the prior week. And if we wanted to, we could drag this down and go to week 9, but I'm just going to leave it at week 8. So here we have 7 of these forecasting periods that we have. So once we have completed our forecasting calculation, we want to know how good our forecast actually was. And there are a couple different ways that we can do that. We need to calculate the error. The error is essentially how off we were from the actual sales. So after week 1, we would have calculated week 2. We would have said, okay, we had 38 sales. Let's, assume that demand and sales are going to be 38 again. So we put 38, but sales actually came in at 42. So the difference between our actual sales and our naive forecast is called the error. And when you plot that on a line, it's a lot easier to see. So let's go ahead and calculate that error. That is going to be our sales subtract our naive forecast. That is 4. Let's do 45, subtract 42. Let's do 40, subtract 45. That gives us a -5. 38 minus 40 is -2. 41 minus 38. And then let's go ahead and do 48 minus 41. And lastly, let's do 52 minus 48. So we have all of our errors here, but we need to go ahead and do some changes to these to be able to calculate our MAD, MSE, and MAPE. First, we don't want to know, if we were to add all these up, if we were to add up 4, 3, -5, -2, the negative numbers would partially cancel out our errors of our positive numbers. So if we were to add this all up, I'll do it right here, I'll do equals sum, and I'm going to add all of these up. It says that my error was 14, but in reality, we were actually 5 away from our forecast, but because it was negative, it kind of throws off our estimate. So what we need to do, we can either square it or we can do an absolute value. An absolute value just takes the positive value. So here I could do the formula absolute, but because it's easy, I'm just going to type them in. So 4 is positive 4, 3 stays positive, it's 3. -5 becomes positive, it turns into positive 5. -2 turns into positive 2. 3 stays at 3, 7 stays at 7, and 4 stays at 4. Another way to do this, whenever we square a number, whenever we take a number and take it to the power of 2, it will automatically stay positive. Because when you do a negative times a negative, it goes to positive, positive times negative, or positive times positive stays positive. So here I'm going to do 4, and I can do that to the power of 2. It would be the exact same as multiplying it by itself. So here I have 16, and I can copy and paste that down, or I can simply do it by hand. So 3 squared is 9, 25 squared is 25, 2 squared is 4, 3 squared is 9, 7 squared is 49, 4 squared is 16. All right, and if I want to double check that, I can. So if I come over here and I do my errors to the second power, copy and paste those down. Okay, it looks like I was right, so I'm going to delete those. All right, the last measure of forecasting accuracy that we're going to use is going to be this MAPE. It is the mean absolute percentage of error. So we need to calculate the percentage of error that occurred from our actual sales that we had. So we calculated our absolute value of our error as 4, and we need to divide this by 42. So we can see the formula down here. It is the sum of our errors divided by the actual. multiplied by 100. So what we're going to do for each row, we need to take our absolute error, so that's 4, and we need to divide it by the actual sales of 42. So that means that my forecast was off by 9.5%. I'm going to go ahead and do that for each one. So I do 3 divided by 45. Here is going to be positive 5 because I'm using the absolute error. 2 divided by 38. Let me do 3 divided by 41. 7 divided by 48. And lastly, I'm going to do 4 divided by 52. All right, let me go ahead and round this to 2 decimal places. All right, so now to calculate these different forecasting summarizing measures, I need to sum all of the errors. So for the MADE, I'm going to sum all of the absolute errors. For MSE, mean squared errors, I'm going to sum or add up all of the squared errors. And for MAPE, I'm going to add up all of those percentage of errors. All right. Now, to calculate MADE, all I'm going to do is I'm going to take 28 and divide that by how many forecasting periods I had. So I have 8 weeks here, but I only forecasted 7 weeks. That's in this example. If you were to extend that to week 9, you would simply do however many forecasting periods you had. So 9, but you skipped week 1, leads you to 8. But here I am only having 7 forecasting periods. That's week 2, 3, 4, 5, 6, 7, 8. So I'm going to do 28 divided by 7. So that gives me an MAD of 4. Now I'm going to do my MSE. So I take my summed up my squared errors of 128, and I'm going to divide that by, my formula says n minus 1. So I have 7, but I need to subtract it by 1, so it's going to be 6. And make sure for your specific class or your specific assignment scenario, whatever, you make sure that you use your instructor's formula. This is what happens in our book. This is the operations management book from McGraw-Hill. I've seen some of this mean squared error calculation where it's just divided by n. Some will do n minus 1. I've even seen n minus 2, like a more statistical measure. And lastly, for this mean absolute percent error, I'm going to take this number right here, and what I need to do is I need to divide it by n, so that is 7. So that gives me 0.09, and I can make this a percentage. So I can make this a percentage right here. All right, and then it's giving me a little warning right here, so let's go ahead and see what it says. It's probably going to tell me it doesn't like that because I'm only dividing by 6, where everything else I'm dividing by 7. So this is how to do the forecasting for naive, but let's go ahead and check out our numbers and how our forecast differs for simple moving average and weighted moving average. For simple moving average, the formula is simply the average of each of the prior periods, however many you choose, and divide that by the total number of periods that you chose to forecast it with. So for example, we are using an SMA of 3. So we're using a simple moving average of 3. So that means I need 3 periods of data before I can actually start making some forecasting. So we want data to build up. We want a little bit to back up, our answers. So we're going to start in week 4 because we need 3 weeks. So after the 3rd week, week 4, we can start to make a forecast. So what is our forecast going to be? It is going to be an average of 45, 42, and 38. So let's come over here. Let's do an average of these 3 numbers. To do it manually, I'm going to do equals, and I'm going to take 45 plus 42 plus 48 and divide that by 3, which gives me 41.667. Repeating. All right, and what I can do, I can actually copy and paste this all the way down. So I'm going to copy this formula, and I'm just going to leave it until the 8th week. And again, you could keep copying and pasting this down. For this example, you'd be able to go to, you'd be able to go to week 9. All right, so I'm going to do that to 2 decimal places, and now we can calculate our error. We need to do our actual sales, subtract our forecasting measure. That gives us 1.67. I'm going to do 38 divided by, subtract 42.33. I'm going to do 41, subtract 41. So that one was actually exactly correct. And then I'm going to do 48 minus 39.67, and then 52 minus 42.33. So these are my errors. But remember, when we add all of these up, it doesn't tell us a true story because positives and negatives can cancel each other out. So I need to do the absolute value. So there's a formula in Excel called ABS, and it will return the absolute value of that number. So I'm just going to reference that number. But you could type it in manually. So I'm going to do 1.67, and it will return to me that number, but the absolute value. For this, I'm going to type it in 4.33. 0 is 0. Awesome. And then 8.33, let's go ahead, 8.33, that stays the same, and 9.67. Our error squared, we can do equals, and we can reference the negative number because when you multiply something by itself, it's going to turn positive. It doesn't matter if it's positive or negative. So I'm going to square that, and that extended my columns a little bit. So I'm going to go ahead and round that to 2 decimal places. And I can go ahead and copy and paste this formula all the way down. All right, and lastly, what I need to do is I need to divide the absolute error, so 1.67 divided by the actual sales number, which gives me 4.1%. Let's round that to 2 decimal places. All right, and then I'll copy and paste this formula down. And now I can sum my absolute errors, which gives me a total of 24. My squared errors give me a total of 184, and adding up all of my percentage of errors gives me 0.52. The mad calculation is going to be 24 divided by how many forecasting periods we have, and we did 5 forecasts. We did week 4, 5, 6, 7, 8. So we need to divide this by 5, which gives me an MAD of 4.79. Let's go ahead and change all these decimal places to 2. And then my MSE, I'm going to take my sum of all my squared errors, and I'm going to divide that by n minus 1. So I have 5 times that I forecasted, so I can do 5 minus 1, so 4. That's where the n minus 1 comes in. Then my MAPE, I'm going to take 0.52, and I'm going to divide it by, how many do I have? I have 5. And again, it tells me, it just shows me an error. It says, hey, you divided this one by 5. You divided the other one by 5. Why is this one by 4? It's because my formula is over here. All right, so now when I look at my naive, I can see MAD is 4. MSE is 21.33. So it looks like in general, naive is actually a better method. But let's go ahead and check some other stuff out. Let's check out weighted moving average. So simple moving average, simply just assume that all weeks were just as equally as important. But weighted moving average does something a little bit differently. So weighted moving average, what it does is it assumes that whatever weeks you choose are a little bit more relevant. So typically what happens is when you use a more recent week, just as like, the week that just happened, that's probably more relevant than something that happened a month ago. So what can happen is you still want the information from those prior weeks, but they're not as relevant. So your weights are something that you can come up with, but if you're in a class, they will be typically be given to you. But what happens here is the week that just happened gets 50% of the weight in calculating your forecast. The week before that, so the second week, gets 25%. The third week gets 15%, and the fourth week gets 10%. So you're using the last 4 weeks to calculate your forecast. Calculate your forecast. There are a couple different ways to do this, but we need 4 weeks worth of data. So here I'm going to go to week 5, so we can use all 4 prior weeks. And what am I going to do? I'm going to equals, and I'm going to multiply my 38. Actually, I can do it a different way. So I'm going to multiply. I'm going to start from the most recent week. So the most recent week was week 4, so that's 40 sales. Multiplied by, what weight do we have? We have 50, or 0.50. Then I'm going to add that together. And then I'm going to take my 45 and multiply that by my weight for the second week, which is 0.25. And then I'm going to take my sales for the third week. I'm going to multiply that by my weight for the third week. And then I'm going to take my 38 and I'm going to multiply it by my 0.10. I can go ahead and do that right here, which gives me a forecast of 41.35. If we were using absolute cell referencing, we could use a formula called sum product, which essentially will multiply 2 different numbers and add them all up. But here I'm just going to keep doing it manually. So we want the 4 prior periods. So I'm going to take 38. So let's do open parentheses. I can do 38, multiply that by 0.5, close parentheses, add that to 40 multiplied by 0.25. And in the prior example, you could see that 40 was worth, 50% of the weight in my forecast. But now, since it is a prior week, I am not going to see it as relevant. And then lastly, I can take 42, multiply it by 0.1. All right, so we have 41.35, 39.95, and then let's keep going. So I'm going to do, open parentheses, let's do 41 multiplied by 0.5 plus 38 multiplied by 0.25. And then let's do 40 multiplied by 0.15. And then lastly, I'm going to do 45 multiplied by 0.1, which gives me a forecast of 40.5. And lastly, I'm going to do, let's do 48 multiplied by 0.5. Add that to 41 multiplied by 0.25. Add that to 38 multiplied by 0.15. And then let's go ahead and do 40 multiplied by 0.1. So that gives me a forecast of 43.95. So each one of these weighted moving average forecasts are a sum of the prior 4 forecasts, but they have different weights to them as dictated right here. So let's calculate our errors. That's going to be the difference between sales and the weighted moving average. That gives us negative 3.35. 41 minus 39.95. That gives us a 1.5, 1.05. Then let's do 48, subtract 40.5, and then let's do 52, subtract 43.95. All right, so remember, negatives cancel out, so you always want to do the absolute value. So let's go ahead, and I'll just simply type that in, 3.35, 1.05, 7.5, 8.05. Let's do the squared of this error, so I can do 3.35, and I can multiply that by the power of 2. So I'm going to take 1.05, take it to the power of 2, and then I'm going to do 40.5, take that to the power of 2, and then what I'm going to do is I'm going to do, I made a mistake. Okay, that was good that I caught my mistake. When doing these calculations, especially in Excel, it's important that you reference the errors. You don't reference the number or the forecast itself, you reference the error. So it's the error squared. Good thing I caught that. That would have been bad. So I can do 7.5. I'm going to multiply that by to the power of 2. To the power of 2. And then I'm going to do 8.05 to the power of 2. All right. And then to do the percentage of error, I do the absolute error divided by divided by the actual. So I need to do 3.35 divided by the actual of 38. I need to do the absolute error of 1.05 divided by the actual 41. I need to do 7.5 divided by 48. And lastly, I need to do 8.05 divided by the actual of 52. So let me come in here. Let me change these to be 2 decimal places. All right, so now I can sum all of these up. So I can do the sum of my absolute errors, the sum of my squared errors, and the sum of the percentage of errors. So MAD is going to be this 19.95 divided by how many forecasts do we have? We have 4. Mean squared error is going to be this 133.38 divided by n minus 1. So 4 minus 1 is 3. And then MAPE is going to be this 0.42 divided by 4. And we can change this to be a percentage, which gives us 11% MAPE, MSE of 4.6, and MAD of 4.99. All right, so now let's compare our 3 forecasting methods and see which one is best for this data. There is not one best forecasting method, but it kind of depends on the data. It seems like the more complex forecasting method you use, kind of the better it will be. But in this case, that might not be the case. So let's stick with MAD, the mean absolute deviation. So we have a 4.99 for the weighted moving average, 4.8 for simple moving average, so that gets a little bit better. And then we have 4 for the MAD. Let's extend a decimal, and it just stays at 4.0. So according to our mean absolute deviation, it seems like naive actually is the best forecasting method. Let's look ahead and look at mean squared error, 44.5, 46.11, and 21.33. So naive also seems like it's better for MAD and MSE. Lastly, weighted moving average 10.6 we have a 10.3, and lastly, we have a 9.1%. 9.1%. All right, so each one of these gives you slightly different pieces of information. So it's important to make sure that you use them in the correct context, but you can kind of get a good picture of what's going on with your data when you look at all three of them in perspective. So one thing that we can do to help us with our insights is if we insert a graph. So if I take my 3 weeks or my 8 weeks, my sales, and my naive forecast, I can add in a chart. So one, the blue line here is my actual sales, and you can see naive is just a perfect copy. Just a perfect copy, you know, and the difference between the blue and the orange line is the error. So sometimes we get lucky and we touch the blue line, but in general, it lags behind. If we do the exact same thing for our simple moving average, if we insert a chart, you know, we can see that the simple moving average seems like it's a lot more flat and there's a lot more distance. So that is where that difference in error comes in. All right, and lastly, we have weighted moving average, which we're not going to have a ton of information just because I only calculated 4 weeks. So let's put in that recommended chart. But here we can see that it's a lot more flat. So when you're using a lot more weeks, when you are actually doing your forecasting, it can seem like your data is a lot more flat. So these are some of the most basic forecasting methods: naive, simple moving average, weighted average. And these are some good summary statistics to tell how good your forecasting was. I hope this video helped you. Please comment if you have any questions. But if not, you have a great day. Happy learning. Keep your head up. You can get through this semester. You can get through whatever you're going through. Have a great day. Bye.